Imagine a volcano, but not just any volcano. Picture a colossal giant, a mountain dwarfing even the mightiest peaks you know. This is a supervolcano. Hidden beneath the Earth's surface it slumbers, a behemoth holding the potential to unleash unimaginable chaos. Unlike regular volcanoes, which are prominent cones, supervolcanoes lie hidden, their immense power concealed beneath vast crater-like depressions called calderas. These calderas, often spanning hundreds of square kilometers, are the silent testament to past eruptions of unimaginable scale. One such giant lies dormant beneath Yellowstone National Park, a popular tourist destination in the United States. Its beauty, with its geysers and hot springs, masks a terrifying secret, a magma chamber so vast it could swallow entire cities. Yellowstone is just one example. Other sleeping giants lie scattered across the globe, ticking time bombs waiting to awaken. The very ground beneath our feet, seemingly so solid, is a thin veneer over a fiery underworld. Deep within the Earth's mantle, molten rock, known as magma, churns and bubbles. This magma, heated by the Earth's core, seeks a way out, pushing and pressing against the Earth's crust. In most volcanoes, this pressure is released through relatively small eruptions, but in supervolcanoes, the magma builds up over millennia, trapped by the immense weight of the Earth above. The pressure builds relentlessly, like steam in a pressure cooker. The Earth's crust groans and strains, unable to contain the growing inferno beneath. The ground above the magma chamber bulges upward, a subtle but ominous sign of the impending catastrophe. When the pressure finally exceeds the strength of the Earth's crust, the result is not just an eruption, it's a cataclysm. Volcanoes, even the most powerful among them, pale in comparison to the awesome might of their larger cousins, the supervolcanoes. The difference isn't just in size, though the scale of supervolcanoes is truly mind-boggling. It's about the sheer destructive potential they possess, a potential to reshape continents and plunge the world into chaos. Regular volcanoes erupt, supervolcanoes explode. A volcanic eruption is a localized event, its impact limited to the immediate surroundings. A supervolcano eruption is a global catastrophe, its effects felt across continents and even across the planet. The key difference lies in the volume of material ejected during an eruption. A large volcanic eruption might eject a few cubic kilometers of ash and lava. A supervolcanic eruption can unleash hundreds, even thousands of cubic kilometers of molten rock, ash, and volcanic gases into the atmosphere. This material, propelled by the force of the explosion, can reach heights of tens of kilometers, blanketing vast areas in darkness. Deep beneath the Earth's surface, in the heart of a supervolcano, a silent drama unfolds over millennia. Molten rock, heated to temperatures exceeding 1,000 degrees Celsius, slowly accumulates in a vast magma chamber. This chamber, a subterranean sea of fire, can grow to an enormous size, spanning tens of kilometers across. As the magma chamber fills, the pressure on the overlying rocks increases relentlessly. The Earth's crust, already strained by the weight of the rocks above, begins to bulge upward. This uplift, though subtle and often imperceptible to the naked eye, is a telltale sign of the growing pressure below. Scientists use sophisticated instruments to monitor these changes. Seismometers, sensitive to the slightest tremors in the Earth's crust, detect the earthquakes that accompany the movement of magma. GPS stations, strategically placed around the volcano, measure the subtle uplift and deformation of the ground. When the pressure finally exceeds the strength of the Earth's crust, the result is an eruption of unimaginable violence. The Earth's surface rips apart and a massive column of ash and gas erupts skyward, propelled by the force of the escaping magma. This eruption column, a towering inferno of superheated ash and gas, can reach heights of tens of kilometers, injecting millions of tons of material into the atmosphere. As the eruption column collapses, it sends pyroclastic flows racing across the landscape. These flows, a deadly mix of superheated gas and volcanic debris, can reach speeds of hundreds of kilometers per hour, incinerating everything in their path. The immediate area surrounding the eruption is utterly devastated, transformed into a desolate wasteland of ash and rock. The eruption of a supervolcano is not a single event, but a series of eruptions, each more powerful than the last. These eruptions can continue for days, weeks, or even months, each one adding to the devastation and spewing more ash and gas into the atmosphere. One of the most immediate and far-reaching effects of a supervolcano eruption is the ash fall. Millions of tons of ash blasted into the atmosphere by the force of the eruption are carried by winds for thousands of kilometers, blanketing vast areas in a thick layer of grey powder. This ash fall is not like a harmless snowfall. Volcanic ash is composed of tiny, jagged particles of rock and glass, abrasive and highly irritating to the respiratory system. Inhaled in sufficient quantities, it can cause respiratory distress and even death. The weight of the ash alone is enough to collapse roofs and bring down power lines. Ash clogs engines, grounding aircraft and bringing transportation to a standstill. It contaminates water supplies, making them undrinkable and disrupting irrigation systems. The ash fall from a supervolcano eruption can paralyze entire regions, bringing agriculture and industry to a grinding halt. Section 6. A global deep freeze. The impact of a supervolcano eruption extends far beyond the immediate area of devastation. The massive quantities of ash and sulfur dioxide injected into the atmosphere by the eruption have a profound effect on the global climate, triggering a phenomenon known as a volcanic winter. Sulfur dioxide, a gas released in vast quantities during supervolcano eruptions, reacts with water vapor in the atmosphere to form tiny droplets of sulfuric acid. These droplets, known as aerosols, reflect sunlight back into space, reducing the amount of solar radiation reaching the Earth's surface. The result is a significant cooling of the planet. Global temperatures can plummet by several degrees Celsius, triggering widespread crop failures, disrupting ecosystems, and leading to widespread famine. The volcanic winter triggered by the eruption of Mount Tambora in 1815, a relatively small eruption compared to a supervolcano, resulted in the year without a summer, a period of widespread crop failures and food shortages in the northern hemisphere. Section 7. Echoes of the past. The Earth's geological record is punctuated by supervolcano eruptions, cataclysmic events that have left their mark on the planet and its inhabitants. These past eruptions provide a sobering glimpse into the destructive potential of supervolcanoes and the impact they can have on life on Earth. One such event, the Toba eruption, occurred approximately 74,000 years ago in what is now Indonesia. This eruption, the largest known explosive eruption on Earth in the last 2 million years, ejected an estimated 2,800 cubic kilometers of material into the atmosphere, blanketing much of South Asia in a thick layer of ash. The Toba eruption is believed to have had a profound impact on the global climate, triggering a volcanic winter that lasted for several years. Some scientists believe that this event may have even pushed the human race to the brink of extinction, creating a genetic bottleneck that reduced the human population to a few thousand individuals. Section 8. Guardians of the Giant. The threat posed by supervolcanoes is very real, but it's not imminent. Scientists estimate that supervolcano eruptions occur on average every 100,000 years. While we can't prevent these eruptions, we can monitor them closely and prepare for the eventuality of an eruption. Scientists use a variety of techniques to monitor supervolcanoes, including seismic monitoring, ground deformation measurements, and gas analysis. Seismometers detect the earthquakes that often precede eruptions, while GPS stations track the subtle uplift and deformation of the ground caused by the movement of magma. Gas analysis can reveal changes in the composition of volcanic gases, providing clues about the state of the magma chamber. While there are currently no proven methods to prevent or mitigate a supervolcano eruption, scientists are exploring a number of theoretical possibilities. These include drilling into the magma chamber to release pressure, injecting cool water into the magma to solidify it, or even detonating a nuclear weapon near the magma chamber to alter its pressure dynamics. Section 9. Facing the inevitable. The eruption of a supervolcano is not a question of if, but when. While we can't prevent these eruptions, we can take steps to prepare for them and mitigate their impact. This includes developing robust evacuation plans, stockpiling essential resources like food and water, and strengthening critical infrastructure to withstand the effects of ashfall and earthquakes. International cooperation is also crucial, as the impact of a supervolcano eruption would be felt globally. Ultimately, the greatest weapon we have against the threat of supervolcanoes is knowledge. By understanding these powerful forces of nature, monitoring them closely, and preparing for their eventual eruption, we can increase our chances of survival and ensure the continuation of our species.